You can see the movie here.
Let's see, can I be heard? Good. Okay, we're ready to start. We have with us today Commander John Young for the first shuttle mission, and pilot Bob Crippen. We'll open our program this morning. The crew has a short film to show you, and they'll speak to that film.
Okay, well, we had a short opening statement to make, too, before we show the film. The mission is the same as it was. It's a 2.5-day mission, 36 orbits, 54.5 hours from liftoff to touchdown. And it's a very interesting mission. There's about 170 detailed flight objectives in the operational flight test program. And we hope with a mission that's been sort of redesigned to accomplish about 130 of those objectives on the first mission. The next mission, STS-2, will involve an Earth orbital reconnaissance package, and so we think we need to be pressing on down to get Space Shuttle operational as soon as practical, and we believe the design of this mission is such that we can certainly do that. Bob?
Oh, the film clip we're going to be showing you is a few little scenarios we've taken from some of our training, and John and I have the dubious honor of probably being the crew that's trained the longest for any particular or single flight. And unfortunately, the film, I think, maybe gives you an idea. All we do is contingency kind of training, which is probably true, not necessarily of the nature that's showing in this, but at least it'll give you some idea of what we've been doing for the past 3 years.
It's all the action stuff. There's no classroom pictures in here. You won't have to watch us writing in our notebooks.
Yes.
Can you roll the film? Just about ready to go, and I can sure guarantee you that Bob and I are too.
Okay, we're ready to open with questions in Houston. Please raise your hand, wait for the mic, and identify yourself and your affiliation.
Is the mic still out?
A mic problem?
I thought it was just me.
Substitutes. Backup comm system.
Okay. I got it?
Test 1, 2, 3. Does that work? Okay.
All right. Sylvan Rodriguez.
Either astronaut. Under what conditions will you go EVA? It's not planned for, is it?
Right now, the only conditions that we have that say we'll go EVA is if we run into a problem with closing the payload bay doors. There are several things that could be associated with that, all the way from a latch not working properly to we have some radiators that deploy away from the door that are utilized to increase the cooling efficiency of our Freon loops, and if those have to be stowed in order to close the doors, or if the door motors themselves did not work. Any of those things associated with the doors would cause us to go EVA. And but again, that's a very unlikely circumstance because there's several backups that would have to fail before you would get in that position.
And we're hoping engineers will come in and tell us the analysis shows that maybe some of those latch groups aren't critical on the payload bay doors. So if they don't work, we may not have to go EVA anyway, just leave them open on entry. I don't think you'd do it for ascent, but for entry, it's certainly a possibility.
George Alexander, Los Angeles Times.
For John Young, John, you've flown the Gemini and Apollo vehicles. You had an escape mechanism available to you from ignition forward. In this vehicle, you don't have an escape mechanism for X number of seconds. Does that make you somewhat apprehensive?
We have an escape system that works for the range where you have air, which is the place where you like to jump out at when your parachute will work, is ejection seats in here, if you had to use them, are out of the SR-71, and they're very good seats. They handle the boost phase almost all the way through staging. Almost for the first 2 minutes of flight. They handle entry from Mach 3 on down, and I think it's a very good escape system. Of course, we don't plan to use it unless we have to. But I think it's a pretty good escape system.
Maybe in some confusion about that initially. We didn't know whether we had, whether the ejection seats would work for the first few seconds off the pad. And we've all been, what they did was weight and balance the seats for us such that we've got a good chance of having them operate successfully straight off the pad. So as far as we're concerned, we've got full ejection capability now where you could utilize it.
Any other questions from Houston? Marty Stebbins?
John Young, correct me if I'm wrong, this is the first time that man has flown aboard solid fuel rockets, using solid fuel rockets?
Well, I expect so, but like in Apollo, our launch escape tower was solid fuel rocket. People don't realize that little escape rocket was as big as a Polaris missile, and so we were dependent on solid fuel rockets for working. All of the Apollo rockets on the first stage, of which there was something like 100, were that caused separation to work properly, were solid fuel rockets. This is an extension of it. The Titan III MOL program was going to use these solid fuel rockets that are very big solids. These are probably the biggest in the world, but we were going to use them. They're very reliable rockets. And Bob and I saw them fire, and they'll make Apollo, they'll make noise like the Apollo program did.
Okay. Yeah, can you wait just a second then?
Bob Crippen, you mentioned that this crew has been trained the longest than any other crew for any single flight. I wonder at what point that becomes a disadvantage in terms of you being ready to go.
As far as I'm concerned, probably never. It's a very complicated spacecraft, and when we initially started training, the training devices that we were utilizing were not fully developed. We had some problems getting our simulator up working properly. We didn't have some of the facilities like this water immersion facility we showed here, and our 1G trainers were not available, and we were primarily doing book work kind of training. It's also a very, in terms of its complexity, the extended training time has allowed us to prepare for much more catastrophic kind of emergencies. As John would say, that if we'd been as well prepared back on Apollo 13, instead of the guys calling down saying, Houston, we've got a problem, they would have called up and said, Houston, we're on mile number 5,332, block 8, taping up the LIO canisters. We've got contingency programs that we're well prepared to handle just about anything, and the extended time has given us that capability.
Howard Benedict, AP.
I'd like to describe, have one of you describe in some detail the 3 abort modes you have.
What's the news conference?
Well, you have at least 3 abort modes. The first one is a return to landing site abort. If you lose a single engine going out of the Cape prior to press to MECO for a single engine out, which is around, nominally is 4 minutes and 20 seconds. Probably it'll be somewhat earlier than that with a normal performance, because that's for 1 sigma low, whatever that means. And so you probably, your turn to landing site abort is you're flying downrange, expend your fuel with 1 engine out, pitch around, turn back toward the Cape. You'll be coming in at about maybe 200 miles, separate the tank at Mach 6.5. You do a 50-degree angle of attack, 2G pull up, and then fly right straight into the Cape and land. From about, when you finish the pull up, you're about 170 out, and you just fly right back into the Cape and land. And then there's the abort once around. The abort once around is also for an engine out after in fact, the RTLS and abort once around overlap a little. And if you lose this engine, you fly around and you land at your abort once around end of mission site at right now it's Northrop Strip, White Sands, New Mexico. And then there's the abort to orbit. So if you lose the engine a little later on down after you've had the press call, well, you can abort to orbit. And the abort to orbit altitude's 105-mile circular, which is a lot less, but enough to stay up there for a couple of days. And if you have extra propellant, which you can evaluate in real time, you can raise the orbit up until you're flying a nominal mission. And those are the 3 abort modes that we have. We have another one called contingency aborts, that if you lose more than one engine, depending on where you are in the flight plan, you can do all kinds of things. The one that we're most enthusiastic about, because it doesn't involve the use of the ejection seat or have to swim too far, is the one where you lose a couple of engines after you get what we call press to rota, which occurs at about Mach 13, and then you can take over and fly the vehicle and land it at Rota Naval Air Station in Spain. After you get a cutoff at about 21,500 feet per second downrange, and you go across the Atlantic, world's fastest transatlantic crossing.
Jules Bergman?
John or Bob, if you lose one engine on the way up, under what circumstances would you continue and just burn the extra fuel, burn the other 2 engines extra long and make orbit? Or is that automatically ruled out?
When we first take off, there's a period of time of approximately a little less than 4 minutes where you cannot go ahead and get into orbit. That if you lose an engine, you're committed to return to landing site abort. And there comes a period of time that is today around 4 minutes, just a little bit less than that, where we refer to it as press to orbit or press to MECO. And it is that occasion that you can lose an engine and still go on up. It is after we get main engine cutoff then that we evaluate how much energy we have as to whether we can go ahead and perform either the abort once around, the abort to orbit, which is a 105-mile orbit, or go into 130 nautical mile, which is what the nominal is. So, and that varies depending on how efficient your engines are burning that day.
But you would burn extra long from the ET. In other words, instead of the ET burning out at 8 minutes, you might burn 10 and a half minutes.
That is correct. You would just burn the fuel longer. You're only burning it through 2 engines.
Laszlo Doza?
To what extent is your vehicle automated? In other words, should you be disabled for some reason, could Houston fly you back?
There's 2 or 3 things that we have to do in here. So that's a very interesting question. There may be some way to work the software where somebody could fly it back. Couldn't get the wheels down, though.
There are a number
Among other things.
Yeah, there are a number of discrete functions that do require the crew on board to throw switches that cannot be handled today through some kind of an automatic uplink form. They involve like starting up our auxiliary power units to go ahead and power our hydraulic systems. They involve going ahead and arming the engines to set up for the retrofire. They involve putting out the air data probes that we use at Mach 3. Today, the automatic system, if it doesn't have air data, it doesn't fly very well. And they involve putting down the landing gear amongst some of the major ones. So today, we are required in order to get the vehicle back.
Roy Neal?
Bob, John, I wonder if either of you ever stopped to think about the implications of what you're about to do. Specifically, this is the first of a kind. As a matter of fact, it's the only machine of its kind for about 16 months. Lord help us all if it aborts. Do you ever stop to think about things like that?
Well, I tell you, I've thought for about 10 years about how important this vehicle is going to be to the United States. There's no question in my mind that the capability to put 65,000 pounds in low Earth orbit, to put payloads up there, much more cheaper than we've been able to do it before, not having to throw away the booster, will absolutely revolutionize the way we do business here on the Earth in ways that we just can't even imagine. It's going to be a remarkable thing, I'll tell you that. And I've been thinking about it a lot. I really believe in it. It's quite a capability. It'll immeasurably improve the defensive capability of the country. It will help develop science and technology. I believe with the Space Shuttle, when we get it operational, we'll be able to do in 5 to 10 years what it take us 20 to 30 years to do otherwise in science and technology, development in space, that we couldn't do if we didn't have the space. You know, we wouldn't be able to do it if we didn't have the space shuttle and that payload capability. And I believe we'll do all those things. And the sooner we do those things, the better off the country's going to be. I believe that too.
This gentleman back here.
Irv Chapman of ABC News. A couple of more elementary questions. First, much has been made that this vehicle makes you much more a pilot, much less a passenger. Would you tell me about that? And also, in terms of the delays, every time they've come to you, for example, the tiles, and now a couple of weeks ago, this new problem, and said, somebody comes and says, fellas, listen, we have another problem. Exactly how do you react?
You're the pilot, tell me.
We swap off questions.
I'll take a stab at it. This vehicle does offer, from a pilot standpoint, it's much more aesthetically pleasing to land on a runway than it is to pop out some parachutes and get dumped in the ocean. It is still a very automated vehicle, and the crew's function primarily is to monitor that everything is going satisfactory. I mentioned earlier some little discrete events that we have to participate in to get it back down, but our primary function is monitoring that everything is going okay. It does involve piloting skills in terms of being able to back up the nominal functions. The crew can take it over and fly it all the way from liftoff to landing. Nominally on the first flight, we will be in the automatic mode up until we basically get over our landing site somewhere around 40,000 feet, at which time John will take over and pilot the Columbia to a landing. But from the standpoint of or looking at it from the viewpoint of a pilot, we're happy to be participating in this particular program. I guess I'll let John handle the delays part. He likes that part.
Well, we've I don't know, engineering problems is the name of the game. When you have a program like this where you're very cost-oriented, you're very cost-conscious, you have to make decisions early in the design stage that are success-oriented, and you find out they don't work out, then you have to go back and fix things. That's just the way the engineering world is, and I don't see anything either frustrating or I think it's kind of disappointing sometimes in terms of the capability that the country needs so bad. We can't get it online any faster. But the NASA's doing the right thing about this. They're analyzing every problem and fixing every problem when they come up one at a time, and I see nothing wrong with that. And as far as being terribly frustrating or terribly disappointed or any of that stuff, I guess I'm personally too old for that kind of thing.
Okay, let's take two more questions from Houston, and then we'll switch to Washington for questions. Morton Dean.
Disappointment. Do you feel that somebody somewhere not only let you two down personally, but let the space program down? Are you pointing fingers at the Congress or at NASA management or the press or the public?
Morton's trying to get me fired again.
Yes, you do.
We did several times.
That was pretty close, Morton. No, I'm not going to point any fingers. That 2010 stuff is no good. I just hope that it'll become evident to everybody how important this vehicle is to folks, and we can supply the high-quality folks and do the job and get it done on time for the next program.
Eric Tanberg.
Tanberg, do you feel that the thermal protection system problem has been solved completely?
When the question came up with regard to the thermal protection system, or our so-called tiles, I assume that's what you're referring to on the orbiter, we worked long and hard trying to figure out what it was that we should do, and there was a lot of talk about developing a capability to go out and repair the tiles, EVA, and question as to whether we're using the right thermal protection system from the very beginning. As far as I'm concerned, that has received extreme scrutiny with regard to its capability. and I have the utmost confidence in it. It has been decided that we are not going to pursue trying to do a repair capability on orbit because that offered all kinds of problems, and it wasn't obvious that it had any desirable cures. The thermal protection system, I just wish that some of the other systems on the vehicle has had the same kind of scrutiny as the TPS has. I think it will work fine.
Okay, let's switch now to Washington and see if we have any questions there.
Hey, this is Washington. We do have questions.
Good.
Bill Hines of the Chicago Sun-Times. To Mr. Crippen, when you said that you wished some other systems had received as much scrutiny as the tiles, did you have any particular systems in mind? If so, what are they, and what are the shortcomings that are outstanding in them?
Okay. I know of no particular system that has any shortcomings, or we would have already been hollering about it. Of course, we can't stand and look over each system in a lot of detail, and it would just been nice to say that everybody had a time to go out and do the same kind of survey of all the systems. No, I'm perfectly confident of all the systems that we've got on board. We've got to worry about the mechanical systems associated with our payload bay doors, the propellant system that's associated with the reaction control systems, the cryogenic systems that fuel our fuel cells. All of those things are critical to getting the vehicle up and down, and they deserve to be looked at. They have been looked at.
Warren Corbett, WDVM. Could you two gentlemen talk about what your routine will be between now and the launch date? What you have left to do? Captain Crippen mentioned that you're the most trained astronauts who've ever flown. What's left on your plate between now and the day of takeoff?
I didn't say we're the most trained. I said we'd spent the most time training. There may be a difference. John, you want to?
Well, this afternoon we're doing ascent skills number 12. Tomorrow from 1 to 6 we're doing integrated entry simulations with mission control. We're doing an ejection seat review from 8 to 9:30 on Wednesday. We're participating in integrated abort integrated simulations from 8 to 12 on Thursday. And Wednesday afternoon, we're flying the shuttle training airplane out at White Sands Missile Range. And on Friday, Thursday evening, right now, we're set up to depart the Ellington Air Force Base to arrive at Kennedy Space Center to participate in the first ascent launch readiness verification test in Columbia Friday morning, and probably Saturday and Sunday we'll be participating down there in those tests. And that's just next week. The government has a way of filling up the time allotted between now and launch with training and things to do somehow.
That's all from Washington.
Okay, why don't we switch to the Kennedy Space Center now, see if they have questions.
This is the Kennedy Space Center, and we do have some questions. Please wait for the mic, and if I don't call on you by name, mention your name. Rob Zeha from Channel 2.
As you may or may not know, negotiations resumed this morning in an attempt to end a strike by 1,000 machinists at the Kennedy Space Center. What advice, if any, do you have for Boeing and the union, and are you angered by the walkout at this critical juncture of the program?
How can we give advice on a matter like that? We don't really, this is John Young speaking, we don't really know anything about it. And I've talked to the folks down there, and I think they're doing everything they can to resolve the business. And as soon as, you know, it'd be good to get it resolved before the flight. But if they don't, I don't have any feel for what effect it'll have. And, you know, after 3 years of delay, we'll just take it like it comes. That's all I can tell the folks there. I'd sure like to see them get this thing going, but on the other hand, folks got to eat too, you know.
Rob Zeha again.
Well, do you fear that the strike could just mean another delay?
I guess as far as we've been told that the strike will not interfere with the launch date.
Gary Whitaker. Oh, never mind. This gentleman here.
Mark Lundner with WCKT-TV in Miami. One of you has been in space 4 times, Mr. Young, and Commander Crippen, you haven't gone yet. To what extent have you developed a sort of old pro and rookie relationship so familiar to TV watchers?
Well, I can say from, this is Bob Crippen, from my standpoint, it's really an honor and a privilege to get to fly with somebody like John Young that has got all the experience and the knowledge that he has. Not only that, he's a real great guy to work with. I guess working together for 3 years, we've had a chance to come to know one another very well, and I think we function well as a team.
Have there been any occasions when Mr. Young has had to, I don't know how to phrase it more delicately, reassure you as to the safety of the endeavor?
No,
Actually, he reassures me.
Gentleman here.
Danik, Swiss Television. It's still not completely clear to me whether or not you can abort with the ejection seats during the burn of the solids.
You just pull the little handle.
I guarantee if you pull the little handle, you will eject, whether the solids are burning or not. And all of the data shows that, that there should be no problem with survivability.
Gordon Harris from Reuters.
When will you be coming to the Cape for launch? How far in advance is the launch itself?
Plan to be down there normally 2.5 days ahead of time. We'll fly the T-38 the afternoon that we arrive down there. We'll fly the shuttle train airplane the next morning. We'll participate in a lot of briefings on systems and weather that afternoon. And, of course, the next morning is launch morning.
All right, let's take one more question from Kennedy.
One more question, Gary Whitaker from Channel 9.
When do you go into any kind of quarantine to make sure that the flu bug doesn't scuttle 3 years of training?
Right now, we're scheduled to go into quarantine 7 days prior to launch.
From KSC.
All right, let's switch now to Marshall and see if they have any questions in Huntsville.
This is Marshall, and yes, we have some questions. We'll begin with Dave Dooling, Huntsville Times.
Okay, I have 2 for John Young, 1 for Crippen, and 1 for both of you. First off, John, when I interviewed you 3 years ago, you said that part of the enjoyment for you in the game was the problem solving, working the engineering difficulties. Are you going to miss them after you have first mission out of the way?
The space business is such that with the new payloads coming along and the many things that we can do with the space shuttle, such as put up some large orbiting space stations very cheaply and inexpensively, I'm sure that we'll always be in the same boat, and we'll be trying to get the most for our dollar out of engineering fixes and things, and therefore we'll probably always end up solving engineering problems. And I see nothing wrong with that. That's the name of the game.
Okay, again for John, this will be the second time that you have made the first flight on a new spacecraft. Excuse me, okay. First time you made the first flight on a new spacecraft, but on Gemini it was a simpler bird and there had been 2 test flights beforehand. How do you feel about making first flight on a far more complex beast without it having been flown in space?
Well, of course, Gemini unmanned flights were successful, and all the Apollo unmanned flights were successful. Maybe one of these days somebody will go back and ask, why didn't we fly those manned? And I think they'll find they could have saved a considerable amount of money and a great deal of time had we done so. Of course, we didn't. So that's the approach we're taking on this mission. I'm very confident because the interface the human being has with this vehicle, it's the right way to go. It cost us a tremendous amount of money and slipped the program many, many months to go unmanned on the first flight, and it really wouldn't be as safe. Really wouldn't.
Okay, for Bob Crippen, you were selected initially for the Manned Orbiting Laboratory Program. Do you expect to be flying DoD-related shuttle missions?
The current plan right now is for the shuttle crew people to be selected for flying all flights, both NASA civilian and DoD flights, are to come out of the office. And it's my understanding that DoD has requested that their flights be done by military folks, of which I'm still one, and I hope I get the privilege of carrying some.
And finally, for both of you, when do you expect to fly again after STS-1?
As soon as possible.
Crippen's right.
That's what we wish. Now, I'm not sure exactly when to. As John says, we got a lot of folks in the office these days, and unfortunately, I guess we'll have to go to the other end of the line. So we're not really sure when we'll get back on for another flight.
Okay, let's switch now to Dryden and see if we have any questions from there.
This is Dryden. We do have one question.
Don Healy, Antelope Valley Press. A storm last week left an awful lot of water on the lake bed here at Edwards. How far down the road will the program have to go before you make a decision to go to Northrop as a prime landing site?
I think that's a mighty good question. I asked that the other day and didn't get a good answer. I think people are looking at it, and they didn't realize Friday in the last mission rules meeting just how much water you had out there. I've heard it from an unreliable, unauthoritative, unofficial source that the lake bed could take from a month to 6 weeks to dry out so that we can come into runway 23, in which case I guess if the launch goes during the week of April 7th, and of course a month to 6 weeks, we'd like to see the Edwards lake bed dry out. We need to go out there and practice some. We'd like to see it dry out as soon as possible, but if it doesn't, I guess we'll have to go to Northrop. Northrop was the place where you saw us shooting these approaches with a shuttle train airplane, and they have two intersecting runways that right now, with runway 17 at Edwards closed, are probably the longest in the country. They're a couple of 35,000-foot long runways, 300 feet wide. One of the things about landing on the lake bed is if you veer off to the side of it, you haven't done anything, where if you land on a runway and veer off to the side of it, like at Kennedy, you might be swimming from the alligators or something, you know. So it's very advantageous on the first flight to go into a lake bed system. We're prepared to go into runways, but we just soon maximize our probability for error.
Okay, did I copy correct? There was only one question at Dryden.
That's correct.
Okay, let's switch back to Houston now for some questions. George Alexander.
John, do you have any plans to enrich Bob's menu while in flight?
Actually, our menus are already enriched far beyond anything that my feeble mind could think of to do to them. The food on there is unbelievable. Rita Rapp has done a tremendous job, and the space program is really, there's some really good food on there, and when you have a food warmer, you have hot meals every day, and it's very nice, very nice. Bob is a chef on the flight, and he can really warm some grits, I'll tell you that.
I'll tell you, I can make up a mean corned beef sandwich, and we've got corned beef on board, too.
This gentleman here.
The entire country right now seems to be a little bit, I know I am, disillusioned by the president's recent cutbacks in NASA's program other than the shuttle. Do you, either one of you can answer this. Do you think that the success of this mission and the other possibilities with Space Lab and the SOC are going to have a dramatic effect on NASA receiving some more generous funds from the government?
Every time I say what the government's going to do, I'm wrong. So I wouldn't even try to estimate what the effect this mission will have. However, I do believe that the capability to use this vehicle and to supply payloads, large payloads to orbit is a vital requirement for the United States in the 1980s and 1990s time frame. And if we get the Space Shuttle operation and rolling, and it does provide these services cheaply, I think it will be a self-generating program that it'll be such a good deal nobody will be able to turn it down, and that's the way the space program ought to be.
Dan Molina, Channel 2.
I know your basic objective in this mission is to get up and get down, but could you be a little bit more specific as to what sequence of events during the flight would amount to a successful mission?
Well, as far as John and I are concerned, if we get up and get down, that's a successful mission. We are, and that the vehicle is in shape to go back up again. We specifically are going to be going through and checking out every system that we have on board, from the solid rockets that lift us off to the potty that we use for waste management. And I guess any of those we could end up running into problems with. And the main thing we want to do is to find out where, if any, problems do exist with the Space Shuttle, and so that we can put it into an operational state as soon as possible. As far as I'm concerned, the prime thing is to get it back so that Joe Engel and Dick Truly can take it up again to fly STS-2.
Yeah, to complete. There is no dividing line, no specific dividing line in terms of, say, for example, the number of orbits between success and failure in this flight.
No, and this being the first flight is a very conservatively planned mission. We're planning to come home every day. We have revolutions, orbits that we can come into the United States, 6 to 7 orbits per day into the United States, into our contingency landing sites around the world, which are Naval Station Rota, Kadena in Okinawa, and Hickam Field in Honolulu. We can come in, there's scarcely an orbit goes by that we couldn't come down if we had a serious problem. And it had to be very serious to come into one of those contingency landing sites, because most of the time we can, even with a serious problem, we can wait on orbit to come into our end-of-mission sites in the United States. And that's what we would do. But the mission is planned so that for a lot of equipment failures, we'll just patch it up and come home. And we have the capability to handle a lot of equipment failures, too. Our in-flight maintenance book reads like a Funkin' Wagnalls. It's a big book, and we can take care of a lot of things ourselves on orbit. And if they get so serious we can't, we'll come back. And our mission rules are set up so that with very few equipment failures on the first day, we'll come back the next day. And then in the same way toward the end of mission.
And I think maybe from a public relations standpoint, we maybe have not done the things such that you people of the press may end up saying, we had a problem, we had to come back early. We talked about the abort modes a while ago. The abort to orbit, for example, we can abort to orbit and carry out, for all practical purposes, a nominal mission. So putting the word abort in front of it, I think, was probably a mistake. We, as John said, have designed the mission so that it is very conservative. If we get a couple of significant failures, we'll come home on the first day, probably on the 5th revolution. And if we get just basically one failure of any significance, we plan to come home on the second day. So I think that the odds, the way we've designed the mission right now, are that we will probably come home early. It's almost, just about anything could break, and we'll decide to go ahead and terminate it. Of course, we also have a way here at the center of evaluating where we're at during the mission, and we may end up electing to real-time change some of those rules.
Jules Bergman.
John, since you're such a big booster of the shuttle, the current rumor flying around Washington is that some missions such as Galileo to visit Jupiter and land on Jupiter unmanned were saved by cutting back on the number of shuttle flights per year. How does that leave you feeling?
It's news to me, Jules. How are you going to put Galileo up there if you don't fly it on the shuttle?
Well, it will fly on shuttle, but you'll pay for it by cutting out certain number of flights in 82, 83, 84, leading up to it.
Well, let me tell you how it works, Jules. You see, people buy for flights on the shuttle, the commercial people and the Department of Defense, and if NASA doesn't have interplanetary payloads, I imagine there won't be shuttle flights on those, but all the rest of them are going to be flown because they're already been paid for by the commercial users. You know, the first 48 flights, there are very few interplanetary flights in there, and they're all being paid for by commercial users or the Department of Defense. I don't know how you cut back on any of those.
Morton Dean?
When would you expect that you will know whether or not you'll be using Edwards as your primary return point or not? And if that decision is made within the next week or so, do you have to alter the final plans of your training for the flight in order to prepare for the alternate landing site?
Well, I might try to handle that one, Morton. There's lots of things that get involved. We have the capability for, on the revolution that we're getting ready to deorbit, when we come over the stateside the last time, to say, hey, you're coming into Northrop instead of Edwards. So, you know, like that's a half hour before the deorbit burn to put in the targets that allow us to come into Northrop. The prime thing that probably ends up dictating whether they switch landing sites is some of the post-mission support. And it takes a while to move equipment from one place to another. And I really don't have a good idea at this time as to when we may make such a commitment. I think they normally, if they're going to transport the equipment over, need something like about 36 hours to transport some of the major equipment. However, we have also tried to put Northrop in condition where it has its own equipment, at least from a minimal standpoint, to be able to support a landing.
Harry Rosenthal, AP.
If you should have a problem that would cause you to be ordered to return immediately, what is the minimum amount of time in which you could get down? You could make the decision and come back down. And the second question is, if something, I know you don't have the capability of repairing the tiles, but if something should happen to the tile, is there anything at all that you can do?
The first question is, what's the minimum amount of time that you could get down? It takes about an unsuited deorbit preparation, which we've run several, when you're just getting out of orbit in a real hurry. What you try to do is wait for your contingency landing site, and that could be at the worst, if you pass over the orbit, landing site at the worst possible time, there's another orbit before you could come down to it. So that gives you plenty of time. You could do everything you have to do, including putting your pressure suit on. But like if you're 15 minutes away from a contingency landing site, and somehow you knew that the failure was so serious that you couldn't make it around to the next orbit, you could deorbit the vehicle and make it to the contingency landing site.
Okay, let's take two more questions from Houston, then close it.
Oh, the tiles? Tiles are in good shape. We're not going to have to repair tiles. They're fixed.
Hey, Jules, let's wait for the mic. Gentleman here.
Hi, I'm Chuck DeCaro. I'm an aerospace writer. Are you going to be carrying a spare GPC, and in case because of the vote down capability of 4 GPCs before you go to BFC? And if you're going to carry a spare GPC, are you also going to carry a spare MDM especially an aft MDM?
I can take a stab at that. Yes, we are carrying a spare GPC, and that was one of the prime drivers for doing that was to get around this problem that I addressed earlier of having to come home early. If we lose a computer, we previously were in a position where we were going to come home early, and for the insurance that it offered, the program decided it would be a good idea to be able to go ahead and carry a spare. With respect to MDMs, we are not carrying spares. We do have the capability to interchange amongst MDMs that are located up in the crew compartment with us. Those are forward MDMs. The aft MDMs are located back near the main engines in a vacuum area, and we have no capability to go out and interchange those particular MDMs.
Carlos Byers, Houston Chronicle.
John, I think you kind of talked around the question of what happens if you have a serious tile problem. You just simply shrug your shoulders and say it won't. What happens if you have a serious tile problem?
How serious is the tile problem?
I think you're a better judge of what would be a serious tile problem than anyone here.
Well, if you don't have any tiles on the bottom, the vehicle's going to burn up. If you have a lot of tiles on the bottom, the vehicle won't burn up. Where the tiles are and what the effect of them is really a sort of an unknown thing. You can lose a tile in a certain area, a single tile, and I don't think it'll do anything to you. My personal opinion is. I've heard people say there's going to be a zipper effect. Well, there really isn't a zipper effect. Each one of those tiles is put on individually, and they're designed 4 to 5 times the strength that they need for the dynamic pressure they're going to see. Now, I'm talking about going into orbit. The tiles are designed, I have to say this one more time, 4 to 5 times stronger than they need to be for the dynamic pressure. The maximum dynamic pressure we can see on the first flight going into orbit is 660 pounds per square foot. The tiles fail at 20 to 22 pounds per square inch. If you multiply that by 144, you see a 2,000 to 3,000 pound capability to handle dynamic pressure, and that's quite a capability. Now, there's a lot of other analysis that's gone into it, including bending and acoustic noise and vibration, that say that those tiles still have a 1.4 safety factor over the maximum dynamic pressure that we can still fly. And that is great. Now, I personally believe those were very conservative analysis. We won't see anything like those kind of dynamic pressures, and I think we got 2 to 3 times the strength that we need in those tiles. That's just from an engineering standpoint.
Thank you very much. We'll now proceed with a short photo session.
Photo session. Hello, Jim.
Yeah, let's go. Here we go again.
There we go again. Seems like we've been here before.